Hello and welcome to Factoring Review. Today I'm going to go through a few factoring problems to help you remember how to factor. We have 4 different types of factoring that we're going to be working with. The first type of factoring is the greatest common factor. So when I'm looking for the greatest common factor, I'm looking for the largest number that divides into all the numbers evenly, and I'm looking for the smallest power that I see. So in the first one, so I will say the largest number that goes in is 6, and the smallest power I see is x squared. And then when I divide that, I will have x minus 3. When I have a GCF, I must make sure I include the GCF as part of my answer. So in number 2, my GCF is 5, the largest number that goes into 5, 15, and 20. And I have an X, and I have a Y. So I'm left with 2x squared y plus 3. The x's cancel out, so it's y squared minus 4x, and the y's cancel out. For number 3, the largest number that goes into 16, 8, and 6 is 2. And they all have at least an x in common, so 2x is my GCF. I am left with 8x squared y squared z plus 4x y plus 3. If for any reason your GCF is one of your terms, you would put a 1 in its place when you ended up dividing. So in the last one, that one looks like there's nothing in common, but we can rewrite this first term. When we multiply, we add exponents, so I could say x to the m times x to the 3 minus x to the m. Now, when I look at that problem, my GCF is x to the m, and then I'm left with x cubed minus, since my GCF is my last term here, I put a 1 in its place. Okay? All right, moving on to the difference of two perfect squares. Difference of two perfect squares is the one that is the easiest. Everything is the same except the sign in the middle. Take the square roots of both parts. So the first one is going to be x plus a and x minus a. For number 2, it's going to be 5y plus 2k and 5y minus 2k. For number 3, I'm going to have mn plus 11p and mn minus 11p. When you're doing the difference of two perfect squares, please, please, please make sure that you have a minus sign. If that's a plus sign, it doesn't work. Trinomials. When I factor a trinomial, my last sign is what dictates what I do. So I am looking for factors of 8 that add up to 6. My factors of 8 that add up to 6 are 4 and 2. When my last sign is positive, that means my signs are the same, and they take the sign in the middle, so they are both negative. Again, my last sign is positive, so I'm looking for factors of 21 that adds up to 10. So my factors of 21 that add up to 10 are 7 and 3. My signs are the same since the last one's positive, and they take the sign in the middle, so they're both plus. So x plus 3 and x plus 7. For the next one, when my last sign is minus, I look for factors of 30 that subtract to give me 7. Well, my factors of 30 that subtract to give me 7 are 10 and 3. And my larger number takes the sign in the middle, which is negative. So it's a minus 10 and a plus 3. Factor by grouping. Remember, we take and we multiply the first times the last. So I have negative 12. And when I'm looking at that negative 12, I want to see what are my factors of negative 12 that give me negative 1. So that would be a positive 3 and a negative 4. So I just rewrite my problem as 2x squared. The middle term would be plus 3x minus 4x and then minus 6. My middle two terms, the 3x and minus 4x, add up to that negative 1x. Now I need to group my terms. I'm going to go over here. And in my first set of parentheses, they both have an x in common. So I take out the x, and I'm left with 2x plus 3. In my second set, they have a negative 2 in common. And when I divide by negative 2, that makes this a positive 2x and a positive 3. Now my parentheses match. So my new GCF is 2x plus 3. And what's left over is x minus 2. For the next one, I do 3 times 1 is 3. My only factors of 3 that add up to 4 are 1 and 3. So this becomes 3y squared plus y plus 4y, sorry, plus 3y. And that is a 3 plus 1. I'm going to group and group. My first set of parentheses has a y in common as a GCF, so when I divide by y, I have 3y plus 1. My second set only has a 1 in common, so I'm just going to put that plus 1 on the outside, so it's 3y plus 1. Now they both have a 3y plus 1 in common, and y plus 1 is what's left over. When you see the words factor completely, that means you're going to have to do more than one type of factoring, or factor more than once. It could be more than one type, it could be the same type multiple times, but you have to factor more than once. So the first thing we always look for is a GCF. And in number 1 here, I have a GCF of 4. So I have 4, and then x squared minus 5x plus 6. I have a trinomial left on the inside. In that trinomial, I see if I can factor it. Are there factors of 6 that add up to 5? Yes, there are, and they are 2 and 3, so it's x and x, a 2 and a 3. My last sign's positive, so my signs are the same. They take the sign in the middle. There we go. For number 2, I need to look for a GCF first. I don't see a GCF. They don't have anything in common. So it looks like this is going to be a factor by grouping problem. So 5 times negative 12 would be negative 60. My factors of negative 60 that add up to negative 7 would be negative 12 and a positive 5. That's kind of funny. There's a negative 12 and a positive 5. So I'd write it as 5x squared. Instead of just having an x, we have to have an ax in the middle. So minus 5, or sorry, plus 5 ax, and then minus 12 ax minus 12a squared. So I'm going to group and group again. These have a 5x in common, and I'm left with x plus a, and these two have a negative 12a in common, and I'm left with a x plus another a. Now they both have an x plus a in common, and I'm left with 5x minus 12a. Sorry about that. It's hard to read that a little bit. 5x minus 12a. That can't be factored again. I think I just put this one in here because it was a tough question with the x's and the a's. For number 3, first thing we have to look for is a GCF. This goes back to that problem we did up on the top with the GCFs. So this can be written as x to the n times x to the second minus 14 x to the n times x plus 24 x to the n. So they all have an x to the n in common, and I'm left with x squared minus 14x plus 24. So now I need to ask myself, are there factors of 24 that add up to 14? And the answer is yes. It would be 2 and 12. So x to the n, and then it would be x, 2, and 12. My factors, the signs need to be the same. They both need to be negative. So that is that one. Last and final question. Y to the fourth minus 81 is a difference of two perfect squares, because y to the fourth, any even power is a perfect square, and 81 is a perfect square. So this is y squared plus 9 and y squared minus 9. The y squared plus 9 cannot be factored because it's a sum of two perfect squares, not a difference. But the y squared minus 9 can definitely be factored again as a difference of two perfect squares. So that's just y plus 3, y minus 3. And remember, it doesn't matter the order that you write your factors in, as long as all of your signs are in the correct place. Other than that, there's really nothing else. This is just a review of what we've done earlier this year and what you've done in the past. And this is getting us ready for our next unit.